and LAS, two laboratories internationally recognized in the field of micro and nanotechnologies, are partners in the LEAF Equipex project funded by the French government through ANR and National Research Agency. The partnership between IEMN and LAS relies on the common interest and complementary views for laser processing techniques devoted to advanced micromachining and lithography. Foldable, lightweight, stackable, high performance. That's the promise that flexible electronics and the integration of heterogeneous functional materials holds today. Smart systems such as wireless sensor networks, micro-aerial vehicles, embedded defense, security and biomedicine chips, environment monitoring, and smart textiles are all applications that flexible electronics and heterogeneous integration would make take off. But such heterogeneous co-integration of multifunctional systems suffers from severe roadblocks associated to the combination of markedly different materials and functional blocks fabricated with incompatible processes. To cope with these problems, the LEAF project proposes to introduce innovative microstructuring techniques based on advanced laser technologies. IEMN develops femtosecond laser photoablation at the micron scale for structuring, milling, scribing, cutting, drilling a virtually infinite range of materials as diverse as semiconductor crystals, metals, and polymers. LAS develops a complementary 3D laser lithography technique for patterning resists with a high aspect ratio and for locally changing chemical or physical properties of materials. Laser microstructuring by photoablation gathers in a single low-temperature and chemical-free processing step what is commonly achieved in 4 steps with conventional microtechnology equipments. This results in a much simpler and cost-effective fabrication sequence. Laser microstructuring holds the advantage to address dimensions, aspect ratios, and materials that can hardly be processed using equipments of the conventional microelectronics industry. It is for this reason that laser processing techniques brings a distinctive advantage and a competitive advantage in the field of advanced microelectronics and photonics packaging, for instance.
This equipment features a femtosecond laser source, and among many advantages, we can say that it totally suppresses what we call the heat-affected zone. Operating a femtosecond laser also involves a special type of light-matter interaction that makes it possible to induce some structural modification of brittle and transparent substrates like glass, sapphire, quartz, which are normally totally transparent at this wavelength.
Our company is specialized in microwave characterization, design and manufacturing of millimeter wave circuits and systems. The main applications are security, defense, medical and 5G telecommunications. For some development, we need to fabricate tiny printed circuits boards with 15 micron thick and 20 micron wide metallic tracks. LEAF can do it and does it. It's much better quality than other companies offering these services thanks to the implementation of original processes.
3D printing has become a new paradigm in the field of rapid prototyping and also for the fabrication of manufactured objects, but its application to microsystems was still limited by the lack of resolution of current system. So in the frame of the LEAF project, we are developing a new generation of 3D printer which are capable of achieving a very high resolution, about 1 micron. And this disruptive technologies allows now the fabrication of microsystems with very complex 3D structure, and this opens the routes for new applications in the field of optics, electronics and also microfluidics.
Laser technology offers several advantages, such as possibility of processing different types of material at different wavelengths, but also facilitating the technological transfer to industrial partners.
Both IEMN and LAS are key members of Rainatech network that concentrates and sustains competitive high-end facilities in the field of micro and nanotechnology. The LEAF laser platforms, as well as the associated technological and methodological developments, are an integral part of the Rainatech network and obeys the same policy of opening to any technological, academic, or industrial projects after technical feasibility appraisal. LEAF has received the support of more than 20 industrial and academic associates and plays a major role in 2 common laboratories with ST Microelectronics and Essilor.